Okay, so today we are continuing with our lead code problems. So today we are going to solve instead of tree problem. Today we are trying to solve the linked list problem. Okay, so we'll go through the NeetCode Blind 150 and try to solve these problems. Okay, so today let's just start by solving the problem. Copy list with a random pointer. Okay. Now let's start a timer. Now let's read through the problem and try to understand the problem before trying to write any code. So the problem number 138, copy list with a random pointer. Okay. So a linked list of length n is given such that each node contain an additional random pointer which could point to any node in the list or null. Okay. So construct a deep copy of the list. The deep copy should consist of exactly n brand new node, where each new node has its value set to the value of its corresponding original node. Okay. Both the next and the random pointer of a new node should point to the new node in the copied list, such that the pointer in the original list and copy list represent the same list state. Okay. So none of the pointer in the new list should point to the node in the original list. So none of the pointer in the new list should point to the nodes in an original list. So for example, if there are two nodes x and y in the original list, where x random points to y, then from the corresponding two nodes x and y in the copy list, x random points to y. Okay. Then from the corresponding two nodes x and y in the copy list, x random points to y. Okay. Now return the head of the copied list. Okay. The linked list is represented in an input and output as a list of n nodes. The linked list is represented in an input and output as a list of n nodes. Each node is represented as a pair of valve random index where valve an integer. Okay, so valve is an integer. You can say it here. Random index. Okay, so random index. The index of a node range from 0 to n minus 1. Okay, that we know that. And the random pointer points to or null if it does not point to any node. Okay. Okay. It's random index. Okay. Now your code will only be given the head of an original linked list. Okay. So let's go through the example and try to understand how to solve this problem. Okay. So example 1. So we have given 7 next as 13, it's next as 11, it's next as 10, it's next as 1. Okay. Null. Then 7 random is 1, 13 random is 7, 11 random is also 1, and 10 random is 7. Okay. So this is given. So what we need to do is 7, 13, 7, 13, then 11, 4, 11, 4, then 10, 2, 1, 0. So 13, 0. 11, 0, 1, 2, 3, 4. Okay. It's pointing to the null. Okay. 13 is pointing to the first element, so 0. And 11 random is pointing to the fourth index element. Okay. 10 is pointing to the second index, and 1 is pointing to the first. 1 is pointing to the zero index. Okay. So simply what we need to do is, like, if there is 7, we have next. So 7 and its second value. We have 7 and its random value. Its value should be the index of the element random is pointing to. Okay. So let's see. 7 and its random is pointing to null. So 7 and null. Then we move on to 13. This is for 13. Its random is pointing to the index of the index in the list with 0. Okay. So 13 and 0. Then we go to 11. So for 11 random is pointing to 1. Okay. Whose index is 4. So 11 and 4 and so on. Okay. So for next example, we can again go through. 1 is pointing to 1 random is pointing to 2. So 1 and 1. Okay, because the index is 1, 0 and 1. Then 2 is pointing to itself, and itself is also index 2. So 2 and 1. So okay. So what we can do is, we have a next node, so we can go through each node, create a hash map that will store itself and its index. Okay, of all of these nodes. Okay, first we can do this. Okay? Then again we'll move to the again we'll move through the list and go through the random and see what's the value of those that in that what is the value of random in that hash map. Okay, so what we can simply do is, let's create an hash map of nodes. Okay, so let's create an ordered map of nodes. Okay, that nodes and int as an index. Okay, so this will be, okay, hash map. Okay, now what we need to do is go through the list till it's null. So while head dot next is not null, what we're going to do is simply head equal to the head dot next. Okay, and we will have an let's have an variable name int index. Okay, and it will start from 0. So what we are going to do is, basically, simply, if our head is not null, we are going to add that to our map. Okay, hash map. So what we are going to do is hash map dot insert. What do we need to insert? Head. We can do this like this. We can do it as head, okay, equal to index. Okay, then index plus plus. Okay, so now, okay, so we have we'll have the index of all the elements and elements and its index in our hash map. Okay, then what do we need is, let's create a node result. Okay, so this will also start from the head. So I'm still not able to understand, like 7 and null. So what is the null? Like, which variable do I need to assign? Like, do I do int val is equal to null, random is equal to null, because it's already pointing to the 13 responding to the 0. So what is the 0? I'm not able to understand that really. So because we have only because in the node definition so we have just valve that will be 7, and then we have next and random. So we already have random as this pointer. So 13 and 0. So what we need, what we should return. I'm not able to understand that, like what we should return as an. We have now result. Okay, return result. That I am just that I understand. So now, what should we return? Like we can now we can move through the again we can move through the list like this and see if it exists in our node. If it's random exists in our node, if it exists, then we can get its value. Okay, we can get its value, but what should we do with the value? Should we change it to change its value to that index?
Oh,
That I'm not able to understand. Like what should we return? I'll just iterate to the linked list and create a copy of a node on the go. Since a node can be referred from multiple nodes due to the random pointer, ensure you are not making multiple copies of the same node. So first we have 7 and null. So what is null? Like 13 0, 11 4, 10 2, 1 0. Like head and the output both are same. What should we return? Like even in this one, like head null 1303. Not able to understand like what should we return? Should we just return head because it does not matter? No, we cannot return head because the head is already null. It is not equal to null pointer. Okay, cannot return null. Let's do this is equal to head. We are able to move through this. And I'm not able to understand what should we return because both head and output are both similar. Node with label 7 was not copied, but node with level 7 was not copied by the reference of original one. Okay, that I get it. So what should I create a copy of all the element as it is? Okay. So like copy list with random pointer. I'm not like so what we're going to do is simply let's create another node. And okay, so and that next it's going to head that next. Sorry, and that next. Then again, and that and valve equal to head valve and random 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 and random is equal to get random. Okay. Now we have created a new node, create a copy of all the elements in the node. Then what we're going to do is head and so this is you don't need point. I'm not able to understand the position first. Like, what are they asking really? Like, should I just create a copy of all the elements in the okay? No. So now for our first element, all of it is copied. We move on to the next element. So while moving on to the next element, we can do also we have this create a node. We have created a node. We are simply very simply are going to do is put n. So created node result is equal to n. So first element. Then we will move on to the second element. We will create a node again result is equal to n. That's not that will not be like that will not be fine because we'll get the last element like this element as a result, but we need this element as a result. We created the copy of the all the elements in the so the result is equal to n. Now if we do result next, now we'll create another node. With a copy of the node. We have a copy of this node, but we are pointing to this, but we don't need to point to this because we haven't even created this node. Copy of the linked list. If we are pointing to this, then again we'll create a next node. Let's create this node. This node should point to this, but this node is not pointing to this node. Okay, so just iterate to the linked list and create a copy of the nodes and go. Since a node can be referred for multiple nodes due to the random pointer, ensure you are not making multiple copies of the node. we have result. Here's m. Then we'll move to the next iteration. Again, we'll create another node that will be this node. Keep on creating nodes. Let's just create nodes. We have created nodes. Create and nodes with vector of nodes. Okay. It's a list of nodes. Okay. So after creating each node, what I can do, I'll dot push back. And now we have copy of all the node. Now what you have to do is we'll get the first element from the node. We'll get it. Let's do this. Now let's do result. So now instead of doing result, now we have copy. Let's create a vector of list, vector of nodes. Yes, now list. Let's add all the L to push back, and now we have this list. So now why L nodes and in L list, what we are going to do is simply take the first node and node dot next equal to, take the first node, its next is equal to the first node, next will be this. Let's do it using for loop. Let's do it using for loop 4 int I is equal to 0 while I is less than L dot size I plus plus. Okay. Now what now what we do is we'll do node I next equal to node I next will be node I plus 1. Okay. Node I random will be simply node I random will be, we'll try to index node I random. So what we need is from the hash map, we'll try to find its random. Okay. Before assigning it, let's try to find int index. Sorry. Int n equal to as map dot find. So if it has not dot find our n. No, we don't have n. We don't have n. We have l. So l. We're going to find l. I. And l. I without random. Okay. If it is not equal to that's m dot end. If it is not equal to null, so what we are going to do is l I random random will be, let's get the value of list I instead. HM no. We done because we cannot do list I because list I is totally different. You have to have a copy of that list. So this will be different. So what we need is, instead of node and int, we will have valve, int and int. So int, that will be valve. So let's go to the, okay, valve is this. So random is null pointer or is pointing to some node in the linked list, and is between the 0 and so what it is, we will not get this. So simply we created a linked list, post everything. Now we'll try to find can this value be seen. Can this value be seen? Let's try this one. Yes. So it's a class. So by doing this, we are, instead of making copy, I think we are not making copy, we are using the reference. Created a new node. And we'll try to find this node in that node. And let's do something that list, it has not find list. It has not find list. Random. Okay. That will give us value. This will give us value. Okay. The index. That will be in this one. And we already have li. So value is the same, so we don't need to do anything with that value. Let's return. Let's return first element of the linked list. That will be L0. So I random. Reference number exists within a null pointer of what node t. While this node is not equal to null. Here that next hit it. If while hit at next is not equal to null, so hit at next is null. So we are also doing hit at next, that is null. So null hit at 12, hit at 12. If head next equal null pointer copy space to here. Null we are not pointer, else let's do this. So if head at next is not pointer, why is this doing this? So let's go through the video solution. Yeah, so actually hash we are using hash, making a copy of a linked list. Haven't we done that already? Like reverse linked list, more sort, linked list cycle, reorder list, remove and node from the list.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve copy list with a random pointer. So we're given a linked list, and so this is a pretty big description of the problem, but it's actually more simple than that. So basically you can see down in the example, this is what you should pay attention to. We have a pretty ordinary linked list, right? So this is a node, and you can see each node has a next pointer, right? So it just keeps going. It's singly linked list for the most part, right? And then we get to the end, right? So this is the end of the list. This is the start. The only difference between this and a regular linked list is that every single node has one extra pointer. It has a random pointer. So you can see that the first node has a random pointer going all the way to null, right? You can see that the second node has a random pointer going all the way back to the first node. You can see the third node has a random pointer going all the way to the last node. So basically what the deal is that every single node has a random pointer, and that pointer could be pointing anywhere, right? It could be at null, it could be at some random node inside of the list, it could be at any of those nodes. So it has a random pointer, but it also has a next pointer, which is, as you would expect, just pointing at the next node. All we really need to do with this linked list is create a copy of it. By that they mean a deep copy. So really what we're doing is for every single node, we're allocating new memory. We're actually creating a new node, right?
Create a new node. Instead of just doing this, we need to okay, new node. Okay. We need to do this like this, and as we can able to transfer the value. Let's do head value. We have created with the value point. This and we need this also will assign to the level. Right, at least we have valid list created. That is now going to be a pointing system. So what we're going to do is create each node in the list. It next would be the next, and it random would be from this one. Okay. So it's random. So while it is not pointed, what will do is list I next putting list I plus 1. If we do this, flow is full. So it's we put 0 of x less than list dot size minus 1 I plus plus. So also getting list at the end minus 1 is what we will do is I next equal to li plus 1. We have only one for the same. Now what we're going to do is instead of having, because if we see here with every iteration we can do also one thing also. We can again start from the head node. Okay. Okay. Start from the fish. Let's do n random will be, let's do head random. Okay, so we can find it. Okay, now let's do then m random equal hash map. And random and random, that will give us the index. This will give us the index of list. Sorry, list list I random will be whatever the country list I random is. Let's that then let's find its index variable that it is. Still we are not able to produce a random pointer. Expected random pointer of node with level 1 pointing to the node from the original list. So first node we have, then again we are changing it to the 0 random will be to find status out. Let's in like I so let's keep on doing 0. Okay, so we are not assigning anything to the hash map, we need to assign things to the hash map. After doing all of this, we need to first for changing the head at m head which head equal to index. Let's do that. So 0. So this will point into the 0. So 0 index. So 0 index. This is pointing to the 0. While two elements are pointing to the 0. Head, whatever the head is, index will be whatever head index. So then 0 next iteration. For this we have 0 1 0 1 2 3 4. For this it's 4. It's fine. So if it is null index, so its random is null. So its random is null. We have 0 1 2 3 4 5. random point. List. We have done this random bit head random, so head random, that will be null. So null. So currently this null for null for null. Zero for one. So just if pointer, just take this complete, else this fits not pointer instead of this complete here. Random pointer available on pointing to the original. This is pointing to the one. So this is pointing to this original. So when we move 1 0 0 0 1 2 3 4, so 4, so 4 we have 0 1 2 3 4 4 minus 1. If I equals equal dot size minus 1, it is it's otherwise let's see just maybe the font. So now let's submit this one. We are getting, okay, so for null pointer it can be 0, so all we need to do is if null pointer, what should we return? What's the answer? What is the, if head equal to 0, what is an expected output? Expected output should be return null pointer. We got correct. The approach which I was taking earlier is correct, but I didn't need to correct a new node. We need to do this like new node. I thought by doing a star node we can create a new node. To create a new node on different location, we need to do this in a different location. Now heap. If we do new, it will allocate them maybe in heap, and then we are doing this, then this again. Now let's go through the video.
And so you can see we have 5 nodes in the input, so we're going to have to create 5 nodes in the output, right? So that's pretty straightforward, right? The only difficulty comes, though, is from the random pointer, right? Clearly, these nodes are going to be linked together, right, in linear fashion, but we also have random pointers, right? So for this node, we would have to create a random pointer pointing at null, right, which is pretty easy. That's what was happening with the first node. But for the second node, right, we'd have a random pointer going back to the first node. And for the third node, we'd have a random pointer going to the last node. So it's not too bad, right? The only difficulty, though, with these random pointers is that, take the third node, for example, right? Let's say we start cloning the node, right? We create a clone of the first node, then we create a clone of the second node, then we create a clone of the third node, and the random pointers, this one's going to be at null, this one's going to point back at the first node, but the third node, right? We know its random pointer is going to be at the 5th node, but we haven't created a deep copy of the 5th node yet. So how can we assign a random pointer before it's even been created? Well, the answer is we're going to do 2 passes. We're going to have 2 loops. And so with these 2 passes, what the first pass is going to do is we're simply going to take each of these input nodes, right? And we're going to create a deep copy of the nodes, right? That's all we're doing. We're just going to create copies of these nodes. We're not even going to link them yet, right? So that's what the first pass is going to do. And in addition, the first pass is also going to create a hash map where we map the original node to the new node, right? So we're going to map every old node to the new copy. We're going to do that with a hash map. And this is going to take place in the first pass. And in the actual second pass is where we're going to actually do all the pointer connecting. So we know that every node is going to have, pointers to the next node. They're also going to have some random pointers as well, right? Like this is going to have a random pointer to the last node. And we're going to leverage our hash map that we create in the first pass, right? That we create using the first pass of our algorithm. We're going to leverage that hash map to map every old node to the new node. So for example, we see in the original third node, its random pointer is pointing at the original 5th node, right? We can leverage that by using our hash map. We can say, okay, in the copy of the third node, we want it to point to the copy of the 5th node, right? And we can use our hash map to get the copy. And so if this doesn't make sense yet, this is just a basic illustration. The copy of the 5th node, right? And we can use our hash map to get the copy. And so if this doesn't make sense yet, this is just a basic illustration. This problem is actually straightforward enough with the code that I think even if this doesn't make sense, when I show you the code, it'll make a lot more sense, because
instead of having an int index like here, we are getting the hash map index. No, we need index, because if we do this random current node and its random node, so if we
at the base, this is a 2-pass algorithm where we create a hash map and can easily solve this problem in linear time, because each pass is going to be iterating through the entire linked list. And our hash map is also going to take linear memory, O of n memory, because we are having to store every single node inside of our hash map. So with that being said, let me show you the code. It's actually easier than you might think. So remember, we are going to have a hash map. I'm going to call it old to copy, because we're going to be mapping every single old node to the copy of that node that we create. So first, we're going to iterate through the linked list once, right? So we're going to have a current pointer pointing at the head. We're basically going to keep going until this current pointer reaches the end of the linked list, aka when the current node becomes null. So the first thing we want to do is create a copy of this node, right? So we can do that with the node construction.
He's writing he's writing Python, so we can go through this to understand in C++. Okay, so so if you have we can return that's simple. Okay, so we created a hash map, but we have created node and integer. We can create node and node. So we'll in first pass create all the nodes. So we created all the node. Okay, so our current node, okay, while current node will going through all the nodes. So creating nodes, and current node spell current text. So we created all the nodes. After creating all the nodes, now we can go current state to head. Okay, so we go to the first node again. Now what we're going to do is from the hash map, we have mapped current node, created a node and added it to the empty. The map current node equal to new node. Okay. So I have created all the new nodes of this index. So I will assign it to the next. So now our current is called to head, while again current is not null. We are going to hash map current next node is equal to MP current next node. So the current will give us the key, and key will give us its value. So its value next node is equal to current next node. That will give us its key, and this will give us its value. So the next element is, so again, current random node. This will give us the value. So values next node equal to whatever the current node random was. So this is also gives us a value. We return this. So let me try to explain how like painting is open. So simply what we are doing is creating a map. As it is. So let's also let's go to the description. Let's add it here. Okay. So in first iteration, what we are doing is keeping it as a key. So these are key, and we are creating a new node as its values. So we have created values. Okay. After creating and the current node as key, keeping current node as key, and creating a new node as its value. So in the next iteration, if we see the next iteration again, what we are basically doing is from the hash map. This is our hash map. Right? So we are saying get me this value. So this will be returned. So this will be returned. Then again we are saying get me this next key value. So this will be returned. Okay. For this node, for the first iteration, simply for the first iteration, what we are doing is saying get me this node value. So this will be returned. Okay. And get me this node next value. If we see this, like get me this node value. So don't look at all of this, just look at this. So what will this return? This will return this one. And then again if we go to this node, this, let's just look at this, what will this return? This will return its next node value. So this will be returned. So what we are doing is value this node next is equal to this node. Okay, so it's simple. Then again we're saying get me this node value. So this will be returned, and get me this node value, and it's random is get me current node random. So let's say the current node random is null. So get me a current random that will be null. So it's null. So current get. So simply our current node, this map current that random will be the value. So if we map it, so this will be null. Okay. So simply we are going to doing its value is equal to null. Okay. simply doing its value. So its value is null. This will return null. It will go and choose the null. So it's simple. Let's try to implement this another. So that's this thing. One second. Let's not remove all of this. Let's just remove this. Let's remove this. Let's create a node start current node that will be head while our current is not null. What we are doing is let's create hash map, okay, of node and new node. The hash map of as current as a key and new node as a value. So we are passing its value, and this loop current is going to get that next. Very simple. We will loop through all this node again. Let's do current is equal to head. Okay, now again while current is not null, what we are doing is let's get the map that is HM. So HM let's do HM. Now let's do hash map HM current. So get me the value of current node. Okay, so this will fill here, it will return the value and its values next node. What do you want? Its current node value next node should be HM, whatever the current node next node value is. Okay. So simply whatever the current node value next node will be whatever the current node next node value is. Okay, so simply this will return this will return this, and it next will be current node next the current